If your timeline is set to 60 frames per second, you have 1/60th of a second to compute and display every frame. If any of those frames take longer than a 60th of a second, then you have to skip frames in order to keep up with real-time frame rates. Therefore, you have to jump your timeline ahead more than one frame at a time. The top graph displays the cook channel, which shows which frames are cooked and which frames are dropped over a 2-second period. The second graph shows how many frames you step forward each display. Time slicing helps you cope with skip frames caused by heavy cooking. The third graph is a sine wave where the values are calculated only when you cook a displayed frame. The bottom graph is the sine wave where the intermediate values are computed in order to generate a smooth curve. So let's start by looking at some basic features of chops. Let's first look at a wave chop. So you lay that down, you can look at the curve inside the chop viewer, and in this tab you can see that it starts at 0, ends at 10 seconds, and is a sample rate of 60. So if we look at the viewer here and turn on D for dots, you can see that every dot is one sample, and if you add it up, you'll end up with 600 samples, 10 seconds long, and this thing isn't time sliced. So let's look now at another chop type. Let's look at the keyboard chop, and this thing's wired to the 1 key, and this chop is different. It's always one sample long. One I means one sample, starting at frame 1. So no matter what happens and no matter what your timeline is doing down here, it is one sample long starting at frame 1. So at this point we can look at the keyboard chop going into a trail to see what's happening over time. So trail gives you a time history. So if we press 1, you can see the time history of 4 seconds of the keyboard chop. We can go here and reduce that to 2 seconds and get a better view. If we go into the trail viewer and press D, we get dots for every sample, and this should be about 120 dots across this channel, so you can see this behavior of it. Now if we go to another chop like a constant chop, we can wire that also to trail, and in this case constant is also one sample long at frame 1, and it's not time sliced, and we can watch the time history in trail. You can see that the channels are kind of steppy, and that means that this system right now is not going at 60 frames per second. The sample rate of the system is up here, 60, and you can set it down here, the FPS. So you can simulate a slow system by laying down a hog chop and setting how many milliseconds or how many seconds you want it to hog, which basically stalls the CPU for some amount of time, and in this case is 0.039 seconds, which is 39 milliseconds, and that's enough to make the channels look a lot more steppy. So yes, some more steppy here, and if we were to increase the hog chop to something like 0.85, it'll get very steppy. Okay, so this is something that we don't really want in Touch Designers. We'd like to smooth it out sometimes. We can do that with a time slice chop, which will fill in the gaps. So we can stick time slice chop in here and ask it to do a linear interpolation in between, and we can now watch the channel, and it's a bit smoother now. We can find out more about the cooking and the frame drops by laying down a perform chop. So perform chop lets you display various system quantities. So in this case it'll be the cook channel. If we send the cook channel to our trail, we can see that not all frames are cooking. So in this graph here we see that it's dropping about 70% of the frames. If we merge together this constant chop, the original one, merge with the perform chop, and then send that to the trail, we can see their relationship to each other. If we go to the trail chop and ask for a graph for every channel, we can then operate the constant chop and we can see the relationship. So here we can see, and we can just pause everything. If we see this up close, we can see on frames where it cooks, the channel, the value changes, but it's held constant from the previous cook to the current cook. With the time slice chop wired in, it makes it look a little bit smoother. So play this forward again, and you can see the behavior. So this looks a little bit better. So some chops are designed to be time sliced to start with. And a good example is the LFO, low frequency oscillator. So it generates waveforms that are repeating waves. If we send that into the merge, we can see its behavior here. If we press H, we can home everything, get in close, make this a little bit higher, and already the LFO chop is filling in the gaps in between cooking frames. So if we go to the LFO chop, you can see why. If you middle click on it and get its info up, you can see that it's cooking 6 samples at a time, and it's cooking the frame range from a previous frame to the current frame. The current frame is the timeline frame. So the LFO is keeping in step with the timeline and cooking enough samples to fill in the gaps from the previous cook to the current cook. Another chop that behaves in the same way is the noise chop. Now, by default, the noise chop is like the wave chop. It is 10 seconds long, not time slice, and it is the full 600 samples long. If we go to the noise chop's common page and click time slice, it'll behave now like a time slice chop. It'll be cooking several frames, and it is also designated as a time slice chop. So if we look at that, send that into the merge chop, and go to the graph and reveal more channels at the same time, we can see that indeed the noise chop is time sliced. So the last thing we want to look at is an audio chop. So let's look at a chop that is a higher sample rate. So the audio chop, let's say the audio stream chop, is generating samples at 44,100 samples per second, and it is cooking a time slice which happens to be around 4,400 samples. And if we look at the audio stream chop, we just freeze everything, go into the audio stream, and getting close to some of the waves and press D, you can see that yes, there are a lot of samples in this wave. And again, this chop is also time slice, so it says time slice, and indeed it is generating enough samples to not interrupt the constant flow of waves. So if we send that into, well, let's say if we just send that on its own into trail, you can see indeed that if we play this forward, we get same kind of thing, the left and right channel, and they're continuously being generated, even though our timeline is stepping forward about 5 to 10 frames at a time. Time slicing doesn't generate intermediate images, SOPs, or DATs. It only generates intermediate chop samples, which is enough to keep a lot of your animation smooth.